Hello everyone, this is V. Manikyala Rao, working as Assistant Professor in the Department of CSE and ML in BVRIT Nasapur. So now today we have to discuss about how to implement the data warehouse and what are the different types of OLAP servers are to be there. Now coming to this one, data warehouse implementation. So the given data warehouse implementation contains these are the steps. So first we have to collect the data from the sources. So the sources are customer apps or enterprise apps, logo and files media. So customer apps or enterprise apps means just like the customers are to view just like the customer apps like Amazon, Flipkart, those all are customer apps. Enterprise apps means that is to be used in the business purpose, just like enterprise, just like website type of apps, websites. Those all are comes under the enterprise apps. So logos and videos means just those whatever were collected, those type of logos. Then the data will be sent into the data warehouse. So here we are having three types of stages: staging, reporting and metadata. Coming to the first one, what is staging means? Extraction, transformation and loading. These three phases are called as staging. So first, extraction means collecting all these data into the source from different sources, and then transformation means it will convert into the suitable format. Then loading means store the data into the data warehouse. Next, after storing these all the data, they will send into the form of reporting. That means the data may be in the form of the report may be in the form of documents. Metadata means the description about the given data, what type of data we are to be collected, and this description will be collected into the data warehouse. Then the data will be represented like this. So after collecting the data, so the data will be distributed like data marts. So sales, finance and marketing means, for example, if you are taking this as a DMart as an example for this one. So in that DMart, the sales department data, marketing data, finance data, HR data, all the data will be there in the individual data marts, and by combining all the data marts, the data will be stored in the single centralized depository data warehouse. So the data will be stored in this all the formats like this after implementing this all the phases into this one. Now in this data warehouse implementations, we are having different types of steps. So first one, how to implement the data cube efficiently. So if first one is, it represents the multidimensional data model cubes and it contains cuboids. So this is called as a cuboid. So it contains total 3D cube, up to 3D cuboid is to be there. So here I will take one example. For example, I want to show city, item and year for some X person. So first, it does not have any data. Next, I will show the city, item and year for that persons. Then that city will be compared with the next item, and then city will be compared with the last one. First one is compared with the second one and the third one. Next, city with item, city with year and item with year. It will not move backward, it will move only forward. Just why we are comparing city with item and then city with year. Next, item with year. So it will not move backward. That's why we are moving only forward actions. So city with item, city with year. Next, item with year. Then we have to combine the city, item and year into the unified source. So generally this combination of 3 points into a single thing is called as cuboid. Why we are calling 3D cuboid means it contains, here 0 cuboid means it does not have any attributes. So 1D means it has only single level attributes are there. Here 2 means each set is having 2 attributes are to be there. 3D cuboid means it has 3 attributes in the single set. Like this, we have to distribute the data in the cuboids. Cuboid means the data will be combined in the 3 combined lines format. So see, in the first one contains 3 lines, the second one contains 3 lines, the next 3 lines. So each and every circle is connected with 3 lines. That's why we are calling as cuboids. So one does not have any attributes, it has single attributes, it has 2 attributes, it has 3 attributes, right? So that is called as efficient data cube representation. So if we have to represent the cube in this syntax format, the syntax is define cube name of attribute names colon operations. So here the cube name. So in previous what we are taking the cube name. For example, the cube name as cuboid. I taken the cube name as cuboid. So in the cuboid attribute names what we are taken previously, the attribute names are city, item and year. The operations, what operations we have to perform? We have to perform OLAP operations, or we have to perform any additional operations or negative operations. These all are the operations we need to perform. So like this, the syntax for the cuboid is this one. So define cube. This is the keywords is to be used. Cube name means we have to take user cuboid name, and then cube is the keyword. Attribute names means what attributes we have to be taken to represent the cuboids. So there are three types of representations for this one: no materialization, full materialization and partial materialization. No materialization means it does not have any data that is not relevant to the existing one. Full materialization means the data whatever we are collected, that data is the exact data about the given things. The next one, partial materialization, means the data we are collected but that is not complete data, that is having some incomplete data about the given statements whatever we are to be collected, that is about partial. No materialization means, for example, the given set does not have any data, that is no materialization. Full materialization means the given set, whatever set we are taking, for example 1, 2, 3 is to be there, that is set is having all the data will be there. Partial materialization means, for example, if I are having 1, 2, next third one is there, but I am not collecting the third value data, just I have collected up to 2 data only. That is partial materialization. Only some amount of data will be collected, the other data is pending, that is incomplete data. About this is incomplete data in this. Incomplete data. That is about partial. So next one, second one, how to implement the indexing for the OLAP operations. So if you have to give the OLAP indexing, they are having two types. First one, bitmap index. First one, bitmap index, and second one is join index. Bitmap index means it is used to compare the given values in the form of 0 or 1s. So how to represent the bitmaps means whether the given comparable values exist means the value will be 1. In case the value is not exist, the value will be 0. For example, I am searching, X is there in the given set or not. I am taking X, Y, Z is the set. Bitmap index means I want to search X, whether the X is available in the given set or not. The X is available in the set means that value will be 1. The X is not available in the set, that value will be 0. This is for available things in the set. 0 means not available. This is for bitmap index. Join index means we need to combine two tables into a single table. So I will give an example, you will understand what is the bitmap index and what is the join index. So see, I have taken one example with the different items or attributes. So we are having different cities and different items and along with the sales. So what we have to represent in this means, first I will show you. For example, I will take the example as Boston. We are having total how many rows? 1, 2, 3, 4, 5 rows. The city is Boston along with the laptops and sales. See what happens in the bitmap index. So in the first one, we are checking Boston. So in the first of Boston is there or not. So whether the value exists, the value will be 1. The item is the particular item. It is a laptop. The sales is 1000. The next one, the city does not have a Boston city. That is a New York City. So that value will be 0. And this value is also 0 and 0. The Boston is not there means that item and sales value is also not there. Next, the third one is there. That value is exists. So that's why this value will be 1. And next one, this item is a phone and this is 700. Next, Chicago. So this value is 0. All the values are zeros. The next one is New York. So this value is also zeros. So finally, what we have to calculate in the bitmap index means we have to combine the numbers like that bitmap index numbers are 10, 100. These all the 5 numbers we need to count. 10100. Then the sum of the value, sales value is 1000, here 1700, all are zeros, so 1000 plus 700. So finally 1700. This is our city Boston value. Like this we have to calculate the bitmap index. So this is about the bitmap index. So coming to the next one, join index. So join index means it is used to combine two tables based on the queries whatever they are given. I will show you with example. So here we are taking the two tables. First one is the sales table. So they are having different product IDs with the amounts with this customer IDs. So see, the next product table contains the product ID somewhat same and the product names will be different. Now we have to join these two tables, sales and the product table we have to combine. So compare these two things. What is the key thing? That means what is the value is the same thing is exists in the between two tables. So here the product ID will be there in both the things. So based on the product ID. So here 101 and 2 there, here 101 and 2 there. That's why we have to combine the things based on the product IDs of the given two tables. So now what I have to write means, so see, select a P dot product name sum of S amount. So that means from the product table we have to collect the product names and the sum of the amounts of the products. So from sales S join product P. So that means from the sales table and join with the product table, then S dot product ID is equal to P dot product ID. So here S dot product ID means in previous one. So S dot product ID means 101 equal to 101 means they need to retrieve the product names laptop and laptop for this one. So next 102 means they need to retrieve the value as phone along with the amounts like this. So now here, so the product IDs will be same group by product name. Now we have to retrieve, so the laptop product ID 101. So the sum of the two numbers 200 plus 300, 500. So why? Because see in this the product IDs here 2 are there. So that's why you have to combine 200 plus 300, 500. For 102 only 1 there. So the 101 2 value is 150. So like this that value we have to show. So they need to retrieve the product name and sum of amount values. So this is about the join index. We are combining two tables based on the unique feature of two tables. So here the unique feature is product IDs for both the tables, sales table as well as product table. So that is about join index. Next one. So efficient processing of OLAP queries. So efficient processing of queries means actually we are having n number of queries are there, OLAP operations are there. We need to perform the OLAP operations by using the multiple dimensional cube. So in this is a multi-dimensional cube. So in the x-axis we are showing items, here y-axis times and the z-axis location. So based on this multi-dimensional table, I want to implement this one in the form of OLAP operations. We are having 7 types of OLAP operations are there. I will show you one by one. So first one is selection. This is one of the type of OLAP operation. So selection contains means it is used to select the particular columns or the values based on the condition whatever we are to be written. So for this, the representation for this one is sigma C of R. C is the selection conditions. That means based on what condition we are retrieving the data. Retrieving purpose that rows values is to be there in the R. So I will show you. So here the attribute name, the comparison operator, the constant value. If you have to compare more than one attribute value means you have to use this syntax. This attribute name, comparison operator. For example, attribute name is item. For example, comparison operator means item name equal to some phone with constant value. Some, for example, that value is 100. So like this we have to initialize the conditions. So in the item attribute, that item name is phone with the 100 value, that value will be retrieved. That is called as selection. Based on the condition whatever we are to be given, condition with the value whatever we are given, so they need to retrieve the values. So that is about selection. I will show you example. See, I taken different types of attributes here. So what I have to retrieve means I want to retrieve sigma team. So the team is the attribute name. So from the team attribute, that means from the team A, particular team column A. So in the team I want to retrieve the data belongs to A from the student table. So this is a student table I taken. The team constraint A attribute, that rows only they need to retrieve. So that means they need to retrieve first row and second row. Why? Because these two contains only team A. That's why they need to retrieve first two values in this. So that is about selection. I want to retrieve only specific columns or specific rows from the given set. That purpose we are using selection. That's why we are using this one, selection. So if we have multiple attributes with the condition, so I already given. So if that is a department, so that means department column with the fees greater than 10,000, the team is not equal to A of the student. So see this example. Not equal to A means first two rows will not be represented. So the next two rows greater than or equal to 10,000 means this third row and fourth row. These all the conditions they have to be set. Team not equal to A means first two rows will not be retrieved. So next two rows CD will be retrieved in the given things. So that is about multiple attributes, selection operation. Second one, projection. Projection means it is used to combine all the attributes into the given retrieved table. So that's why I taken pi of attributes A1, A2 and so on. These all are the attributes with the relation operation R. So I will show you with example. This is the relation operation. Relation operation. A1, A2 and so on, all are the attributes, subset of attributes in the given example. So I will show you what is that relation and what conditions we have to be taken in the projection. So see in this. So we are having this the employee table. I want to retrieve only few rows from the set. So employee ID, name and department salary. Actually we are having 5 rows here, but I want to retrieve only 4 names. I don't want to retrieve the age value from the given data set. So for that purpose we are using projection. But in case of selection means it is used to select only particular values from the set, particular row of values. But in case of this one, we have to select only particular columns from the set. All the values have to be there in the columns. That is about projection. Next one, third one is drill down. Drill down means it is used to move down. So they need to move down in the concept hierarchical manner and they need to add new dimensions. See this example. Actual things are products are to be in x-axis, time is in the y-axis and these all are the things. So they need to move down means they need to elaborate the given dimensions into more dimensions. See here we are having 4 quarters. So actually for example if you are seeing the year, we are having 12 months. So here the time contains how many quarters? Quarter 1, quarter 2, quarter 3 and quarter 4. Drill down means the given minimum things is to be elaborated into maximum things. So that's why I have divided this 12 months into each and individual contains 4 months. So Q1 contains first 4 months, Q2 contains next 4 months, Q3 contains next 4 months, next 3 months, 4 into 3. So 4 quarters, 4 into 3 months we have to divide. So see, first January, February, March, these 3 belongs to quarter 1. Next 3 belongs to quarter 2 and next 3 belongs to quarter 3 and next 3 belongs to quarter 4. So drill down means we have to elaborate the given quarter of dimensions into more dimensions. Here we are having only 4 dimensions, but we are adding that one into 12 dimensions. Everything, the upper thing will be same. Only these 2 things, this product thing will be same. But only this time value, y-axis value will be drilled down. That means elaborated the given things into more number of values. So that is about a drill down. Next one, roll up. This is the opposite of drill down. So that one will be changed. So see here in the dimension, in the drill down, they need to increase the quarters into more. Here it is used to decrease the number of values into smaller set of values. So see this example. So this one, x-axis will be same, y-axis will be same. Roll up, that means we are moving into up direction. So we are moving into up direction. So see, this New York and Washington belongs to the USA. And this Bangalore and Turkey belongs to the ASEAN state, Asia. So these 2 are combined into one thing and these 2 will be combined into one thing. Those 2 will be combined, USA and Asia. So USA value combined 400 plus 550, 950. Next Asia 600 plus 450, 1050. So here the Asia value is 1050. This USA value is 950. So these 2 belongs to USA and the Bangalore and Tokyo belongs to, these 2 belongs to USA and this belongs to Asia. Roll up means it is used to combine or reducing the dimensions. Drill down means it is used to increase the dimensions. Roll up means it is used to decrease the dimensions and that is dimensions belongs to this axis, Z axis dimensions will be changed. In case of drill down, X axis, Y axis values will be changed. Roll up means the Z axis, top Z axis values will be reduced. We have to reduce those 4 dimensions into these 4 dimensions into 2 dimensions. That is about roll up. That's why written we have to reduce the dimensions in the concept hierarchy manner. Next one, slicing. Slicing means the given data will be converted into single dimensional cube. The given data will be converted into 2 dimensional cube. So slicing. So see this picture. So I divided this one into single dimensions means we have to take these products along with this dimensions numeric table. Only Q1 quarter, whatever the things is to be there, those values we are taken here and that values we have to represent. Only single dimension values from this set. So 2 dimensions means here we are combining two quarters here. So mobile and tablet, 2 dimensions we have to be taken. So for this mobile and tablet, so 2 quarters along with this 2 are to be taken. Any for each dimensions we are taking two set of values. Here we are taking only 1 dimension values. Here we are taking 2 dimension. 1 dimension values means the product will for 1 quarter, for the single quarter values with these 2, with these all the years of this product. So that products along with this first Q1 values, quarter values with this all the things is to be there. Single dimension way. That means only 1 dimension cube is to be there in this. Dicing means opposite of slicing. So it has only 1 dimension. It has 2 dimensions. That means we are taking Q1 and Q3 and out of these 4 we have to select any 2 and then here also we have to select any 2. 2 values will be retrieved from this. That is dicing. 2 values. Here it has only 1 set of values. Next one, pivot operation. So pivot operation means it is used to transfer or transport the x-axis into y-axis, y-axis into x-axis. So see, so these are the cities is in the, we are having in the x-axis and these all are in the y-axis. So pivot means they need to change x-axis into y-axis. So see here, the city is in the x-axis, but here the city is in the y-axis. Products are in the x-axis. Axis value, x will be changed into y-axis, y will be changed into x-axis. So this is about the data, how to implement the data warehouse with the different types of OLAP operations. Next one, how to implement the OLAP server. So actually this OLAP server is used to implement with the multi-dimensional models. So these all the multi-dimensional models is used to store all the OLAP data, and that OLAP data with different formats I will show you. So see, these are the different format types of OLAP servers are to be there. Now coming to the first one, ROLAP. ROLAP means Relational Online Analytical Processing. So in the Relational Online Analytical Processing, what happened means it is used to store all the data with the relations of tables. The table data will be there in this relational OLAP. All the structured data will be there, and that, for example, some x, y, z is there, 1, 2, 3 values are there. Like this, the data dot, all the dot database type of data will be there in the Relational Online Analytical Processing. Coming to the MOLAP, Multi-Dimensional Online Analytical Processing. So in the multi-dimensional means it is used to represent the OLAP cubes. Cube means they need to show the given data in the form of x-axis, y-axis and z-axis. And the next one is HOLAP. HOLAP means hybrid OLAP. Hybrid OLAP means it is a combination of relational OLAP plus MOLAP. It is used to show all the relational structure data tables, and it is used to show the given data in the form of multi-dimensional data cubes. That means they need to show the data in the form of x-axis, y-axis and the z-axis. That is HOLAP. And coming to the next one, so other types. WOLAP means web OLAP. So the data is to be collected from the web, all the online sources, different types of online web sources we have to collect, that is web OLAP. And next DOLAP, dimensional data OLAP means that is used to collect all the data that is belongs to the given, whatever the dynamic type of data we are to be collected from the given websites. That dynamic online analytical processing data will be there. And next one, MOLAP means multi-dimensional online analytical processing. It is used to store all the data in the form of, actually this one, this MLOP and this one will be same. Multi-dimensional cubes only we are storing the data. And SOLAP means it is used to store the data in the spatial online analytical processing. Spatial means it is used to store the data in the form, just like we have to use this one in the form of Uber, Ola, delivery type of things we have to show spatial. So R means relational, M means multi-dimensional, H means hybrid, next W means web, D means dynamic, M means multi-dimensional, S means spatial. So OLAP means online analytical processing. By using these type of all the servers, and we have to store all the data with the implementation of the data warehouse. So this is about the different types of OLAP servers and how to implement the data warehouse in the given structure. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.